All right, last element of a well-designed experiment is comparing your results. There seems to be a difference in the response variables, but is it big enough? And what we're asking is that difference larger than we would expect based on random chance? If so, then we call the results statistically significant. And that's our goal in statistics. We're not proving anything. We're just saying it's probably not random. That's what we mean. Probably not random. Probably wasn't just lucky guesses. It wasn't just pure luck that it worked out this way. Probably wasn't random, but it was statistically significant. Okay, and that's the goal of comparing our results. And we will get to more and more definitive ways when we get to inference about whether things are statistically significant or not. Okay, some of the important things that we want to be careful of is blind and what's called double blind. All right, the subject and or the people who measure the response variable, we want them to know or not know what treatment they receive. All right, so if the subject is blind, the pills of the placebo and the actual treatment look identical, so they can't tell which one they're receiving. All right. Typically, if the person who is measuring the response variable, if it's a subjective thing that they're rating it on based on like how bright their skin looks or how thick their hair seems, you don't want them to know which hair treatment they got because they're subjectively measuring, and if they know this was the new experimental treatment, they might subconsciously favor that. Okay, sometimes you can't keep people blind. Like if I'm telling you to exercise or not, you can't be blind to the fact that you're exercising or not. If it's chemotherapy or some other like electromagnetism therapy for cancer, you can't be blind to the fact that you're receiving chemotherapy or not. Okay, it's impossible to keep people blind to some things. And so sometimes it's unavoidable, but typically you want the subjects to not know what treatment they're receiving whenever possible. And if the person measuring is subjectively giving a rating, you definitely want them to be blind to what treatment the subject was receiving. Okay, and the last thing I want to talk about here is a match pairs design. We're going to do this in class. We're going to do some match pairs experiments, but you match similar subjects ahead of time. So you might match twins together. Okay, we got a few of those in my AP Stats classes. You might match the left and right hand or left and right foot of someone. My favorite is if you want to treat boot leather. LL Bean is trying to treat leather on their boots, okay, to see which one makes it easier to clean the leather, keeps the stains off. Rather than sending half the people leather treatment A and the other half the people leather treatment B, you have each person randomly assign one treatment to the left boot and one treatment to the right boot. And then person A, if person A doesn't go anywhere muddy and they just go to the mall all the time and both their shoes are clean, at least you're comparing two boots that have both been in the same terrain. And person B has been climbing up mountains and jumps in mud puddles and is just crazy. You're comparing the two treatments on two boots that were both in exactly the same places all the time. Okay, so it maximizes the similarity between treatment groups and gets you more precise results. This is one of the most ideal ways that you can get really clear, statistically significant results because you're minimizing the variability between your treatment groups and making them as literally similar as possible, okay? And so when you're comparing, we're looking for statistically significant, and these all help to get there. All right, that is a well-designed experiment. Replicate, random assignment, control, compare, watch those videos again if you're still not sure what those things are, and then ask me about it in class. We'll be doing plenty of experiments. See you soon.